All right. So I'm going to walk through these just so we can see them. Most of us got through most of them. Love it. On this one, you have a lot of choices. We could, and I saw some people do that, where we multiplied the whole thing out, starting by squaring this thing when we get our x minus 4 times x minus 4, and expand that out, then distribute the 3, and then minus 2, and then all the other things. That is a valid option. That is the hard way, though. The easy way on this is to get this piece by itself first and then use our square roots. So if we take this and we, instead of trying to multiply it out, add 2 to both sides to get 3 times our x minus 4 squared equals 27. Then, still trying to get that purple piece by itself, divide both sides by 3. We get this piece that's a perfect square, our x minus 4 that's a square, that equals 9. So if we do it like this, then we can use the fact that to unsquare something, we can take a square root. That gives me the x minus 4 equals, whenever we square root both sides, we need to include the plus or minus, and the square root of 9 is 3. It's like absolutely valid, and you still got to the same roots. Absolutely valid. Because that's the way your brain went. I was following your brain. You were not the only one. But to get our roots, we find when our x minus 4 equals positive 3, and when our x minus 4 equals negative 3. So for both of these, we're going to add 4 to both sides. And we're going to get root at x equals 7. And when I add 4 to both sides here, x equals 1. So you did it. You did totally fine. And multiplying it out, and for some of us, that makes more sense in our brains. And that's okay. But this is usually shorter. But this is also the only time we don't have to set it equal to 0. For our factoring or for our quadratic formula, we do have to set it equal to 0. What's up? Quadratic formula. The benefit of it is that it works every single time. Every single time. It'll even work if we wind up with imaginary roots. Oh, snap. So, again, I saw a couple people do this one. Hard mode versus easy mode. Hard mode involves multiplying it out. Most people that multiplied it out then used quadratic formula. Totally valid. That's multiplying it out. Easy mode, when we are in factored form, we find our roots by setting each piece to 0. So 2x minus 1 equals 0, and 6x plus 5 equals 0. That is absolutely a valid way to get to our roots, our solutions, our zeros, our x-intercepts, those guys. You got to the right answers. It's win. It wins. It's the long way. You go. It was the scenic path. You went for a lovely walk through the woods on a beautiful hike.
You could have thrown me a log, bro.
I didn't want to derail your train.
You could also do it like this.
Your train of thought was chugging. I wasn't going to turn you around. You were cooking. But on these ones, I could go ahead and add the 1 to both sides for this green one over here, so that we get.
Multiply every single one, and then you just put it in. That's exactly what you
That's valid. That works. We have calculators. Calculators are a wonderful tool. We can use them. Totally works, especially since we're not doing most of the math in our head anyway. No, the last one is it goes that way. Yeah, because that one's decimally and super gross.
Of course, I do the ones that.
All right, so on this purple one, we follow the same kind of vibe. We subtract 5 from both sides to get our 6x equals minus 5. And this one winds up fractiony, but tolerable because it's minus 5/6. I would have to do paperwork. Please don't make me do paperwork. Yeah. You can and you can put it as a decimal or we can put it as a fraction. Genuinely, I don't care. Okay.
We just write 0.83. Would it still be considered right?
If you show this, absolutely. Absolutely. I do not care if you do it as decimals or fractions. The only time I ever ask for more than one way of writing it is if we have something that requires the quadratic formula, where we might want to have it as a exact form, which is when we have it as a radical versus as a decimal. So this is going to be the kind of one, and we can really tell with our fraction here, this would be a pain in the butt to try and factor. I don't really want to put this into vertex form. If I did put it into vertex form, I could solve it this way, but this vertex is going to be nasty. I don't want to do that. So this is one that I would consider to be the strongest candidate for our quadratic formula. And again, I'm going to give it to you on the test. Minus b plus or minus square root b squared. X equals negative b. X minus square root b squared minus 4ac all over 2a. Oh, there are so many songs to help you learn it. And in fact, when I was in 8th grade, we marched around my middle school chanting it like a creepy little math cult.
What's that song?
Oh, no, it was just to chant. It was just x equals negative b plus or minus. Imagine marching past a kindergarten classroom chanting that. It was a creepy little cult. Dude, it was 30 years ago. There's no video. So on this, we just substitute in our pieces. So we're going to have our minus 4.7. What's up? Our 4.7 squared minus 4 times our a, which is 9, times our c, which is negative 6. Be careful with these when we're substituting in. Make sure to get the signs in the right places because that minus 6 makes a huge difference if we lose that minus sign. You will, in fact, get something that gives you an error. So on the review, it talks about the discriminant and finding the value of that. That's just simplifying this guy under here and getting the actual number of that, where we simplify this to have our minus 4.7 plus or minus the square root of, and we would just type in our 4.7 squared minus 4 times 9 times negative 6, and I don't have it pre-written down. But we get our value under the radical, I'll do it in orange, is 238.09. And 2 times 9 gives us 18. So this would be our exact radical answer. To get the decimals, I split it up and I type it in the calculator. So this is what we would put for our radical. To put it in the calculator, you can use our fraction button, and then if it tries to leave it in radical form, which it might, we use this button that looks like this to get it to be a decimal. If it gives you a radical form, I will most likely ask you for both. So if we have something that gives us a gross decimal like that,
Is that right?
we should get, for our x's, a minus 1.12 or 11834, blah, blah, blah. And
we got over here 4,700. Oh, no, this is a negative. Oh, no, that's not. That's negative.
that as times -4. Okay? Here. If we go back, we swap this thing out for the minus. It is barely a visual difference. So this is to subtract something, they'll be better
Okay.
times -1.
Wait, you do that on.
Okay?
So, you do that on.
Okay, so it should look something like this.
Did you?
Is that,
Type it in.
get your 4.7 up on the top, but other than that, glorious. So. Oop. Have it. If you start with a fraction. Because you want to get your -4.7 on the fraction as well. I say, usually I can go back and fix it, but when the square root's in the front, it gets super grumpy. Okay? So simplifying the bit under the radical helps very nicely to do some of these things. Monday, we might work through a little bit more, but for the most part, that's going to be all we do in here. There's a few more pages in the chapter in the book, but we were trying to get it wrapped up before spring break, so I didn't want us to do our tests after spring break because, ew, gross. So there's a couple of pages in the workbook that we're just not going to do because I didn't want us to wind up having the test be after spring break or on the career fair day where we lose like 20 minutes in class. So our chapter test is on Wednesday of next week. If you need a copy of the review, I have them over here by my desk. I'm more than happy to give you one. I have plenty of copies. They are right here if you need a copy of it. Here's chapter review right here.